Okay, so for this recording, we will cover about random numbers, loops, which includes the for, while, and do while. So first, about random numbers, which I will include in our final exams. Um, Random numbers, as the name says, it will help you generate a certain number and maybe make use of it as for guessing games, for maybe you need certain decisions that you need to use random numbers. So maybe later you will realize or come up with a solution that might help you with random numbers. So in C, if you are going to use a random number, you will need to use a header file, which is the steady lib or standard library. So first, you need to include the stdio, then you need to include the stdlib, and next you'll be needing to include the header file, which is time.h. So these libraries, I mean the two libraries here, which are essential for you to use functions for you to generate random numbers. Although, if you may stumble upon later, or I mean, if you'll stumble a tutorial, you might see that there aren't preprocessor or header files included in their code. So that means that in some cases, C implicitly adds this library if you are using some functions that are included in those libraries. Like for example, if you use the random function and you forgot to include the stdlib, and somehow you notice that your program still works, well, that means that the C compiler implicitly, so meaning uh, it just does it for you, no? You just include it for you, so to avoid errors. But it is recommended, although it does it implicitly. I still recommend to explicitly. So meaning you will be the one to add it, because later, if you create uh, what do you call it, enterprise level programs, there is a possibility that your program may be installed in different operating systems. So different platforms may produce errors because you forgot to add these libraries. So to make it short, you'll just have to include the libraries which you're going to use for a certain function. So let's proceed. So of course, our main function. So there are a step for you to create or generate random numbers, and that is for telling the compiler what seed or certain value you need. I mean, there's certain value that you need to give so that the random generator will work, and that function is called srand. There you go. So srand, it means seed, no, seed random. So meaning that is where the random generator will decide what would be its seed, no, so that it could come up a certain value. So first, you need to call this function, and you need to add a certain value, like for example 1. So let's try that, and let's try to print a random number. So if and for you to generate a random number, you will have to call the rand function. So srand and rand function belongs to the stdlib library. So always remember that or memorize that. So just to see it how it works, so let's just save it and then run, and you will have here a value which produced a value of value 41. So that's supposedly the random number. But if we're going to run it again and still uh, pass the number 1 value to the srand function and run it again, and you'll see that it still gave you the same number. So there's no random value generated, so it's still the same. So for you to generate a unique random number, so you need to supply a certain value in the srand function. So maybe let's try to and run it again, and now you receive the number 45. So if you're going to run this again, obviously you'll still receive the same number. So how can we pass let's say certain value that it will guarantee you to have a random number? So in that case, you will need to pass not a literal value but rather a function, so that we will have, so it will guarantee to have a random number. So as you can see here on the third header file, you will see a header file called time.h. So time.h is a header file that contains several functions about date and time. So in C, you could manipulate or receive a certain date and time. So in our case here, we will use the time function. And what we need to pass in the time parameter is the value of null. So what does this mean is the time function will return the current date and time in decimal, or I'm sorry, or in integer. So to see that, let's try to comment this out first, and let's see what it looked like. So %t new line and time, of course we have to pass the null value. So if we're going to run this, oops, get an error again. So run it again, and this time we receive a big value, right? So that means, so 1 2 3, that's 100,000 million, and so it's 1.7 billion. So let's disregard the rest of the value. So basically we receive a billion number, right? So it's 1.7 billion. So as you can see here, if we're going to run again, so remember the last value, so this one, and we're going to close this and run it again. And if we're going to compare it, you'll notice that before it is the last 3 digit is 157, but now we receive 200. So what does this mean? What is this value? So basically this value is the representation of the current date and time. So as you have known, time is not constant. It always changes, right? Down to the seconds, down to the milliseconds. So it is a good idea to use time as a seed for our random generator, or for us to come up with a random value. So going back to the first and second line, so if we're going to use this, we are guaranteed to have or receive a random number. So if we're going to run this again, so this time we receive 22,579. So let's close this and run again. And this time we receive 22,612. So that's it. Our random number generator now works properly. So next, what if we want a certain random numbers to only generate a certain what I call that, a certain limit, right? Let's say we want the random generator to just random between 1 to 10, right? Or 1 to 100 or whatever. So in that case, we will use the modulo operator or the percentage, and most of you have already know what this does. So for those who don't, the modular operator returns the remainder of the divided number. So for us to generate between 1 to 10, so we just use the modular operator and then the limit that we want. So in our case, let's try it between 10, right? So let's try to run it again, and we receive the number 3. So close, run again. And this time we have 9. Run again. So 9, 2, 5, 8. So as you can see here, I'm trying to run the programs, because what I'm trying to do here is to show you that there is a possibility that there will be a zero value in the result, right? So let's try to make this between 1 to 5 only, to make the odds lower. Okay, still 4, 2. So as you can see as well, it is generating only between 5. Okay, so here is the number that I want to show you. So notice that we have a zero value here. So as what I said earlier, we want it to generate between 1 to a certain number, right? So 1 to 5, 1 to 10, and so on. So for us to avoid the zero value or the zero number, so we just simply add by 1. So in our expression here, let's update it and close with parentheses, and this time we add 1. Okay, so maybe let's only generate between 2, right? 1 to 2. So this is just to show you that the zero value doesn't show up. Okay, it's 2, 1, and still 2. Or we could just simply, let's say our random number should only generate between 10, 5 to 10, right? So this means that all of our numbers doesn't include 0 to 4, and doesn't include numbers above 10. Okay, hold on, there's something wrong here. So we saw our number 14, which is isn't right. Okay, so what happened earlier, we received the number 14, right? Which shouldn't be, because we only allowed between 5 to 10. So I forgot to add a parenthesis to first evaluate the random number, and then we modulo it by 10, and after that we add by 5. So what happened earlier is it adds up 10 and 5, so that means our random generator should generate between 0 to 15. So that's why we received the value 14, if you were paying attention. So to avoid that, so there is a change in the expression. So to do it right, so we have first to evaluate the random number and then modulo it by 10, and after that we add the number 5. So this makes sure that we only generate numbers between 5 to 10. Okay, so again, this is the maximum number, so modulo should follow it, and then the number 10, or the maximum number, and then after that we add it by the minimum number. Alright, so that's how we can generate random numbers in C. So you just have to memorize the libraries first, the header files, stdlib or stdlib. So that is where the srand and then the rand function belongs to. So without this, you cannot execute both function. But as what I've said earlier, if you really forgot to add these header files, C or the C language will implicitly include the header files, but it is recommended to include it explicitly, because there's no telling that in the future your program might run on a different platform, and on different platforms it might require explicitly including these libraries. Okay, so again, we use stdlib to use the srand and then the rand function, and we include the time.h to use the time function. So time will be the one we're going to use as the seed for our random numbers. So we will pass it in the srand function. Again, srand stands for seed random. Okay, and for us to get the actual random number is we're going to use the rand function. So you could use a lot of applications here if you're going to use the rand function. So later we will do some examples that where we can use the rand functions. Okay, so moving on, the next will be the for statement. So for statement is part of the looping or iteration statements of the C language. So we have actually two types of loops. So we have two types of loop. So two types of loops or iteration. So we have number one is the variable counter. So meaning that our loop will repeat until a certain value has been encountered or satisfied, and the other one is the sentinel iteration. So sentinel iteration means that the loop will repeat indefinitely, or we do not know our loop will stop until a certain input from the user or from an external software or API has been reached or has been satisfied. So like for example, our loop will stop if your user has given a negative value, or a software does not respond to our program anymore. So that's when our loop will stop. So something like that. So again, the variable counter means that we already know when our the repetition will does itself, right? So variable counter will only stop until a certain value is reached, while the sentinel iteration is when our program receives a value from the user, and maybe that value satisfied our conditions. So the first loop that we have in C is the for statement. So for is represented by the keyword for, and it has three parameters. So our for has or contain, the first parameter is the initialization. Condition, and then the steps. So the first parameter here, that's the initialization. The second parameter is the condition. So meaning the condition is when or how will our repetition stop. So when will the statement stop, right? So that's the condition. And steps. So in what manner our repetition will loop. Is it by 1? Is it by 2? Or is it by 3? Etc. So steps kind of like when you are stepping on a ladder. You can step it by 2 or you can step it by 3, and those other steps are skipped, right? Like for example, we only want to loop the odd numbers, we are only going to loop the even numbers, and so on. So that's the steps, right? So for example, in initialization we have to add a certain variable, so that will be the variable counter. So it will be the variable who will going to reference on when we are going to stop our repetition. So we can either declare a variable inside the initialization like this. So we usually use the I for index, no? So that's the common variable, or what do you call that, no? Identifier for a certain loop. Then next is, let's say for the condition, let's say we will stop until our we will only loop if the value for our variable counter, which is I, is between 0 to 9, right? So notice here the relational operator here, so we have here the less than. And of course our step, so we can add it by 1, or we can use an increment, or we could just do this, I plus 1, or to make it short we could do this. So I plus equal to 1. So meaning it is a shorthand for I equals to I plus 1. So that's the shorthand. So for this for statement, our variable counter will start from 0, and it will end if the value reaches to 9 number, right, to the value of 9, and it will, every time the loops will repeat, it will add this value or the one value to our variable counter. So let's try to print, let's try to make this simple. So let's print the current value of I every time our loop starts, right? So I. So let's try to run it. Oh, sorry. So I'll have to comment this out first. Okay, let's run it again. And as you can see here, we have started from 0. That is because our variable counter started from 0 and it ended on the value 9. That is because our condition here that it will only, that our I, the variable counter, is only less than 9. So meaning above 9 is not acceptable. Or we could use less than equal. So meaning our variable counter is only between 0 to 10. So if we're going to run this program, so earlier you see that it only shown the value from 0 to 9, but this time it included the number 10 because our condition is less than equal 10. So take note that the steps will only execute after the loop, right? So on the starting loop, it will not execute. So let's say our variable counter will start from 5, right? So obviously, if we're going to run this, you'll see the numbers between 5 to 10. What if we're going to step it by 2? That one. So it means that every time our loop starts, it will add, I mean by the end of this statement, it will add the value 2 to our variable counter. So if we're going to run this, then you'll see that the first loop, our variable, the counter variable is only 5, and once it starts to loop again, it will add number 2, so that gives us 7, and after that it will add another 2 and it gave us 9. So that's how the for statement works. So as long as you memorize this parameter, then you are good to go. And in some cases, we could do reverse, right? Not just from lowest to highest, but we could also do highest to lowest. So if you want to start from highest and then loop until a lower value has been reached, then you could do, of course, you could initialize our counter variable into a higher number, let's say 10, and our condition should be our variable counter should be above 0. Then it will start to loop. And of course, we cannot add value since it will contradict in our condition. So take note that it will only run if our I is greater than 0, or in our case here it will loop infinitely. So let's try to run this. Oh no, there you go. As you can see here, our for statement is in an infinite loop because the condition is illogical. So as you can see here, our steps here, it keeps on adding up. That's why our condition here is still running, because as you can see here, it will run if our variable counter is above by 0. So once it reaches the value 0, that means it will stop on repeating. But in our steps here, we keep on adding up. So to avoid that, so uh, we have to deduct value not adding up. So in our case here, we'll just deduct by 1 each time the loop restarts. So let's try it again. And as you can see here, it started from the value 10, and then it goes way down to number 1. Right? So of course we can change our steps. We could subtract it by 3 every time the loop restarts. So if we're going to run this, then you'll see that the first loop, the value is 10, and then when it restarts, it will deduct 3, and that gives us number 7, and so on. So that's how the for statement works. So that's the variable counter, right? So what if it is a sentinel type of iteration? So again, sentinel iteration is we don't know until the value has been reached. So for that, for the sentinel iteration, we could maybe use while loop for that. But we will just have moving on. So let's proceed with the while loop. So we will see later. So in while, this is the syntax for our while statement. So of course it uses the while reserve word or keyword, and inside our while is the condition. So you could use different expressions here as long as that expression is true, right? Let's say I is less than 10, right? So something like that. So unlike for, our variable counter for while should be outside our while statement. So integer I versus 0. So take note that it needs to be outside the while, because it needs to be remembered. Because if we're going to add it here inside the while, so that will become a local scope variable, right? So we need to be to declare it outside our scope. So in our while, our variable counter should be either added up or deducted depending on the condition that we want. So in our case here, we want it to be added up, no? Because our condition is our while will only repeat if the value of the variable counter, which is I, is less than 10. So that means it's less than 10, meaning 9 and below. So that includes 0 and negative value. But in our case here, we already initialize the variable I into 0. So that means between 0 to 9. So in our variable counter, it needs also to have a step. So that means we need to increment, decrement, or add or deduct a certain number. So in increment, it will only add one value, or decrement, it will only deduct one value. So these uh, should work, no? So as long as you have the initialization, and you have the condition, and you have the step. So that's how the unlike the for statement, uh, it's it will be added on the same area, but in our while it's kind of like scattered, right? So we have here the initialization, which is outside our while scope. The condition is the parameter that we need to pass in our while statement, and I should be within the scope of our while. So let's try this just for example's sake. So same case in our for, we'll have to just print the values for our variable counter. So let's run this, and obviously we will have the same value. So we can even start, let's say, to 4. So as you can see here, it's 4 to 9. Or we could change the steps. Let's say instead of adding by 1, we could just add by 2. And there you go. So we only see 3 values because we changed the step and then the initial value. So this is an example of a variable counter. What if, right? What if that we are going to use a sentinel iteration? So again, sentinel iteration, it means that we don't know the value yet until it is given to us from a user or a different entity or a software or API. So let's try to change this. So instead of so what we could do here, let's say we will only run until I is not equals to 0, and then maybe we could do value for I is, and then we don't do some steps here because the value for our variable should be coming from our user. So let's say printf and we'll use scanf, and we use the formatting scan %d address operator I. So we are going to do a switch, and we're going to switch I, and let's say case, if case is 0, then let's say no, not yet. No, yeah, so case, let's say, no, let's not just use some switch. Let's say if um, I is greater than 0, then we could use let's run again, or maybe let's play again. Then else, so let's say printf, then do goodbye. Okay, so our program here should only run if our I is not equal to 0. And if it's still, so first the iteration or loop will display the current value of our variable I, and then after that we will ask for a value, and then later determine what's the value. So if it's greater than 0, then we'll just display this sentence, and if not, it's going to say goodbye. So if we're going to run this, and what happened here is it did not execute our loop or our while. That is because our initial value for our I, or the variable counter, is already equals to 0. So to do that, let's change the value to 1. So that means our condition has already been met because our I is equals to 1 and not by 0. So basically, as long as it is a non-zero value, then our while will run. Okay, so there you go. So the first loop is it run, so it displays the 1 or the value of 1, and it will ask for another value. So let's say 56. Then it says let's play again. So it's already printed here, and it looped again because the condition is satisfied, so it's not equal to 0. So next is it will going to display the value of the current value of I, and then next it will ask again for another number. As long as it's not 0, then it will keep on running. So 3 or 8 blah 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 8,000 whatever 3, right? So it kept on running. So this is an example of a sentinel iteration, because it doesn't know when to stop until a certain value from our user has been given. So in this case, as long as the value is not 0, then it will keep on running. So this time we're going to give value of 0. Then that's the time it says goodbye, because the condition has not met, because our I is now 0. So our condition here, the while will keep on running until our I is equals to 0. So again, the while loop or iteration will always ask for the value of our counter variable, and if it's not met, then it will not execute, right? Because since earlier we saw that the initial value of I is 0, so obviously it will not run there. So no execution happened, or maybe in this block did not executed because our loop did not satisfy the condition. So what if our iteration will at least execute once. So if that's the case, then we're going to use the do. So we're just gonna interchange this and add the condition at the end of our block. So now this is a do while iteration. So do while. So do while is the opposite of the while, because do will, as the name says, it will do the first loop, and then after that it will evaluate the expression. So in our case here, in while, earlier our while will not execute because we already initialized the value of I into 0. But using do while, it will execute the program first. So let's try to run this, and as you can see here, it already initiated or executed the first loop. So on the first loop, it displays the value 0, right? That is because that's the initial value. And this time, it will ask for a new value for our counter variable. So we'll do a larger number. As long as it's not 0, then it will keep on running, right? So that's the use of do while. It will execute first and then ask, while the while loop will ask first, and then if it's met, or if the condition is met or satisfied, then it will execute. So that's the very simple explanation of while versus do while. There you go. And as you can see, it ran into an infinite loop because I accidentally pressed the in the keyboard. I accidentally given a character. I mean, in my input, there was a character included, so that's why, as you can see, it goes into an infinite loop. So that's the problem, because our loop will only execute if its I is equals to 0. So that's it, no? So that's the difference between the while and the while. So later in your activities or on your lab exercises, I will give you problems that involves using these iterations. So that's it for now. So ask me, no, in the chats or in the Google Classroom later on. So thank you for watching.